tracing its roots back in 1901 from the then Bureau of Government Laboratories, which became the Bureau of Science, the Department of Science and Technology, Industrial Technology Development Institute, or DOST-ITDI, turned 119 years old on July 1, 2020. From basic researches to mapping of the country's flora and fauna and other local resources for scientific studies, DOST-ITDI has been a vital instrument in establishing the research and development agenda in the country. It was 1958 when the Bureau of Science became the National Institute of Science and Technology, NIST, that industrial R&D started gaining ground while harnessing local resources and skills towards self-sufficiency and optimized productivity. Industrial R&D went full gear in 1987 when the NIST was renamed Industrial Technology Development Institute, focusing on 4 major functions: research and development, technical services, technology transfer, and custodian of the national units of measure to provide international traceability. DOST-ITDI research and development covers 5 major areas: food, environment and biotechnology, chemicals and energy, material science, and packaging technology, all aimed at supporting and answering the needs of local industries. Complementing its R&D are its technical services, standards and testing, national metrology, and technology transfer, aimed at harnessing local industries' productivity and competitiveness, and translation of developed knowledge or innovation into the production sector, paving the way for new businesses or startups. As well, DOST-ITDI innovations serve as springboards for businesses to thrive and prosper. In support of the administration's thrust in addressing the COVID-19 pandemic, DOST interventions are anchored on the theme, Aghama Teknolohiya, Sandigan ng Kalusugan, Kabuhayan, Kaayusan, at Kinabukasan. At the height of the COVID-19 pandemic, and when most of the country was in enhanced community quarantine, DOST-ITDI bravely rose to the call of duty, distributed ready-to-eat foods such as the Pack of Hope and Mungbean Cocoa Milk Drink to our frontliners in Metro Manila and other regions in the country, produced face shields via 3D printing and donated these to hospital frontliners, developing prototypes and 3D printing critically important parts of hospital equipment, and improved design of N95 masks to better protect the frontliners. The Institute is also providing interventions for our displaced countrymen who lost their jobs and livelihood by making training available online whenever necessary. And even before this pandemic, DOST-ITDI innovations were critical in rehabilitating communities that experience calamities and even war, and make them whole again. DOST-ITDI has been preparing for an innovative ecosystem for new knowledge and technology to thrive and help make us ready for Industry 4.0. DOST-ITDI aims to achieve kaayusan and ascertain the future or kinabukasan through its initiatives and help businesses and every Filipino adapt to COVID-19 under the new normal. State-of-the-art facilities are being established. Construction of the Simulation Packaging Testing Laboratory, SPTL, and Green Packaging Laboratory, GPL, is ongoing. At the SPTL, stress conditions that affect products during transport are simulated that can help mitigate losses during distribution, while produced products can be processed and packed in a green packaging laboratory. AMCen, or the Advanced Manufacturing Center, DOST's 3D Printing Technology Center, is a joint project with Metals Industry Research and Development Center, MIRDC. ITDI focuses on developing multiple 3D printing materials from local materials to reduce cost. Halal Food Research and Development Facility. With this facility in place, the Institute hopes to develop new food products that are compliant to halal standards and as well support DOST as it responds to Republic Act No. 10817, or the Philippine Halal Export Development and Promotion Act. Enhancement of the competence and capabilities of the National Metrology Laboratory of the Philippines. Expertise and facilities are being upgraded, and construction of laboratory facilities for metrology and chemistry and biology are now ongoing. It is envisioned that the NML will provide the country with credible measurements, and traceability in the fields of physical, chemical, and biological metrology. And with the emergence of the COVID-19 pandemic, DOST response has been decisive. With the support of President Duterte and the Interagency Task Force for the Management of Emerging Infectious Diseases, the DOST will establish the Virology Science and Technology Institute of the Philippines, or VIP, to be constructed at the new Clark Economic Zone in Capas, Tarlac. The VIP shall be pursuing priority virology research and developing diagnostic kits, therapeutics, and vaccines for diseases caused by viruses, where DOST-ITDI will have a critical function.
From laying the groundworks for science and technology in the country, the Industrial Technology Development Institute of the Department of Science and Technology, through the years, which turned 119 last July, has been consistently providing innovations to industry to help make them competitive, emerging as a credible industry partner. The Institute has been instrumental as well in mitigating hazards and improving the lives of disaster victims and communities to rise again. With so much optimism with this cooperation and bridging of talents and expertise, we look forward to enhance science, technology, innovation, competitiveness, and the emergence of new research and development capabilities that hopefully will translate into new products, services that meet the current and future needs of our nation and the people. To our dearest Secretary Fortunato T. de la Peña, Undersecretary Rowena Cristina L. Guevara, distinguished guests from the academe, government agencies, Fab Lab, manufacturing industries, our industry partners, DOST colleagues, my ITDI family, friends from the media, isang magandang umaga, mga kaagham. Una sa lahat, nais ko kayong pasalamatan sa pakikiisa at pagsuporta sa forum na ito ukol sa Materials Development o MATDEV. I recall that it was on December 22, 2020. That was last year when we inaugurated the AMCen-MATDEV laboratory and opened to the public the entire facility, unveiled its state-of-the-art equipment and apparatus like the 𝘿𝙚𝙥𝙖𝙧, the very first time in the Philippines, its capabilities and the line of technical services it offers. On that day, we witnessed the fulfillment of one of the DOST's big ticket projects for 2020. MATDEV, or the Development of Multiple Materials Platform for Additive Manufacturing, is part of the DOST's Advanced Additive Manufacturing R&D program, or AMCen, that is jointly implemented with the DOST-MIRDC. MATDEV focuses on developing local materials for 3D printing that can reduce cost and increase the use of locally available resources, while DOST-MIRDC's rapid ADMATEC undertakes the advanced product prototyping. Nang magsimula ang pandemya last March 2020, mabilis na kumilos ang DOST to help ease up and fight the spread of COVID-19 infection sa pamamagitan ng paglikha at paggawa ng protective gears and devices gamit ang 3D printing technology. DOST-ITDI's MATDEV team, led by former Material Science Division Chief Dr. 𝘿𝙚𝙎𝙧, produced the 3D printed face shield holders, developed prototypes of 3D printed respirator venturi valves, prototypes of parts for the multiple patient ventilator splitter and mechanic ventilator mini war zone, to name a few. The team never stops and it continuously working hard and thinking of measures to lessen the impact of the pandemic. Ang araw na ito ay sadyang mahalaga. Magkakaroon tayo ng talakayan at pagbabahagi ng mahahalagang impormasyon at kaalaman ukol sa mga proyektong patungkol sa materials development. Kasabay nito, mabibigyan daan na marinig ang mga pangangailangan at problema ng industriya at komunidad kung meron man, at makabuo ng mga hakbang at solusyon na kinakailangan. Again, here I stand before you, grateful for this opportunity to serve the country and our fellow men using local technology and innovation. I encourage all of you to actively engage and share your insights as well as raising your concerns and needs. This way, we may determine how we may be able to help you with your needs, with what we have, how we can serve you better, and together help invigorate socioeconomic development and growth through local technologies. Let us join hands in building a better future by finding ways to make our expertise and facilities work for everyone. Allow me to give thanks and congratulate the organizers of this event for this successful activity. The Material Science Division, led by the officer in charge, Ms. Josefina Silorico, Engineer Marianito Margarito, the project leader of MATDEV, and the rest of the MSD staff, Ms. Nelia A. Florendo, the Chief of the Technological Services Division, and the rest of the TSD staff. Muli, maraming salamat sa inyong pagdalo. Pagpalain tayo ng may kapal, manatili tayong malusog at ligtas.
Secretary Fortunato T. de la Peña, Director Annabel V. Briones, officials and staff of DOST Industrial Technology Development Institute or ITDI, partners in media, partners in industry, friends and colleagues, magandang araw po sa inyong lahat. A few days before Christmas last year, we were blessed with the inauguration of the Materials Development Facility of the DOST Advanced Manufacturing Center, or AMCen, housed at the Materials Science Division of DOST-ITDI. Now we are here at MATDEV as stakeholders for the future of innovations in materials development and additive manufacturing. The MATDEV facility aims to undertake research and development, or R&D, of materials such as polymers, plastics, metals, ceramics, and composites for advanced manufacturing using local and indigenous materials. This is crucial for the material science industry as it can reduce the cost of raw materials and increase the utilization of local resources for high-end and high-value applications. This has been proven especially when COVID-19 broke out last year. Saludo po ako sa mga miyembro ng MATDEV team na kahit may health risks dahil sa virus, ay nag-3D print sila ng napakaraming gamit para sa ating mga frontliners, from face shields and ear protectors to ventilator valves and respirator components. Malaking tulong po ito sa ating frontliners, lalo na sa mga hospital at iba pang mga medical institutions, lalo na at nagkukulang tayo sa parts at supplies ng medical equipment. With AMCen-MATDEV, we can now continue developing advanced and sustainable materials for medical technologies, food packaging, transportation and defense, among others, from which various industries can truly benefit from. Innovations such as this could go a long way in our efforts to be responsive and self-sufficient in this field, especially during these trying times. Sa pagpupulong na ito, nais naming ipaalam na handang tumulong ang DOST para matugunan sa abot ng aming makakaya ang mga pangangailangan ng industriya. I encourage all of you to participate in this dialogue and express your insights on how best we can be of relevance and service to your sector. Nais ko pong pasalamatan ang lahat ng mga nandito ngayon. Thank you for saying yes to us, saying yes to MATDEV, and together, Let us take materials development or MATDEV to the next level at gawing kapaki-pakinabang para sa ating mga industriya. Muli, magandang agham po at manatiling ligtas po tayong lahat.
Isang mainit na pagbati sa ating mga kasama sa larangan ng pananaliksik, negosyo, pagpuproseso at pagmamanufaktura. Additive manufacturing is one of DOST's priority programs. Under the program, it has two projects, namely the development of multiple materials platform for additive manufacturing led by ITDI and rapid and advanced prototyping for product innovation and development using additive manufacturing technologies steered by MIRDC. On March 15, 2019, we had a groundbreaking ceremony. Additive manufacturing played a great role in providing 3D printed devices to fill in the shortage of medical devices and personal protective equipment, to include face shields, face masks, and bulbs. Until now, ITDI is still distributing face shields to hospitals and clinics in Metro Manila, thanks to the 3D printers available at the Multiple Materials Development Facility at ITDI. Why is additive manufacturing important? It allows the creation of lighter, more complex designs that are too difficult or too expensive to build using traditional dies, molds, milling, and machining. Whether additive manufacturing is used for prototyping or for production, lead times are frequently reduced. Here in this forum, I am enjoining the manufacturing industry representatives to adopt advanced manufacturing and make use of the 3D printer services and facilities of ITDI. Additive manufacturing is a great alternative to those companies that are dedicated to manufacturing goods on demand. Additive manufacturing is here to stay. I will not bore you with lectures on its applications. No, I won't do that. What I would like to do is to share with you what I see us doing together in the next 5 or 10 years ahead. First, allow me to clarify what additive manufacturing can and cannot do. Why go into this thread? We need to see where we are right now and where we might be soon. Additive manufacturing, or AM, is a process of making a product by adding successive super thin layers of material. It is often referred to as 3D printing. Compared with traditional production methods or subtractive manufacturing, AM requires less hard tooling and assembly and offers greater customization or bespoke manufacturing at a shorter time to market. It can reduce the obsolescence of spare parts, which is particularly important in asset-heavy industries such as aerospace, automotive, and medical devices. In some countries, the use of AM is widespread in machineries like turbines, in materials handling equipment, in robotics, in lifestyle like jewelry, in sports like biking, and in custom parts of classic cars. Interestingly, I read that it's now possible to 3D print human body parts. In the long run, AM can completely change the way products are designed and built, as well as distributed, sold, and serviced. AM is where we might be soon. But right now, most of our manufacturing firms are into subtractive manufacturing or subtractive fabrication. Subtractive manufacturing, as we know it, involves cutting away from a solid block of material. It could be a block of, for example, metal, plastic, or wood. A milling machine cutting, hollowing out a piece of metal or plastic is an example of subtractive manufacturing. So are you now excited or still not quite convinced? As it currently stands, it is unlikely that additive manufacturing will replace subtractive manufacturing at any time soon. This is because both sets of processes have a very contrasting set of advantages and disadvantages, meaning that each can play to the strengths of the other's weaknesses. AM, as it is ideal for manufacturing prototypes with complex geometries, but with little wastage. It is ideal for rapid prototyping because the digital process means that design alterations can be done quickly and efficiently during the manufacturing process. The low material wastage provides cost reduction for high-value parts. Also, parts that previously required assembly from multiple pieces can be fabricated as single objects, which can provide improved strength and durability. If you are now convinced with the idea of AM, here is what lies ahead of the business. The global additive manufacturing market by value is expected to grow at a compound annual growth rate, or CAGR, of around 15% from 5.31 billion US dollars in 2015 to 21.5 billion US dollars by 2025 due to increasing demand for 3D printing from industries like automotive, dental, manufacturing, and healthcare. This is from Frost and Sullivan's Global Additive Manufacturing Market Forecast up to 2025. Likewise, during the forecast period, the market will shift from prototyping to mass production of parts and accessories. By 2025, it is predicted that additive manufacturing technologies will enable companies to produce finished products on a large scale. In the era of additive manufacturing, it is no longer necessary to use welding machines to fuse steel sheets or to employ cutting machines to mill components, as the job is done by industrial 3D printers. These marvelous machines are produced by the likes of Stratasys, 3D Systems, and EOS. Certainly, right now, our industries may be thinking of how and where to integrate additive manufacturing in the grand scheme of things. So what's our value chain? Who will be the players? And what will the business model be? The AM landscape is diverse. Currently, here is how other industry players out there are doing it. In the plastics printing market, larger integrated players cover the entire value chain from supplying materials to manufacturing printers to providing printing services. In the metal printing market, by contrast, relatively small players focus more on certain parts of the value chain, such as in printing equipment or printing services. Small players are looking at consolidation for capital. In some places, niche players are growing fast. These companies ground their entire business models on additive manufacturing. For businesses that are into distribution of original equipment, reports show new competitors entering the original equipment manufacturing, or OEM, market. Large players are certifying end-to-end processing for producing medical parts. These were formerly purchased from OEMs. Looking at the positives, there are several entry points for the integration of additive manufacturing in the subtractive manufacturing sector. Not all sectors, however, may need to go the additive manufacturing way. One needs to check the economies of scale first. Again, I urge you to take advantage of the multiple materials development facility of ITDI. Let us collaborate, do partnerships and linkages. As Steven Anderson, who is a famous educator, said, "Alone we are smart. Together, we are brilliant." Muli, isang mainit na pagbati sa inyong lahat.
All right, thank you very much to that message of support from our Secretary Fortunato T. de la Peña. And I would like to acknowledge that he is here with us via Zoom. Good morning, sir.
Good morning, good morning.
Thank you very much for your presence and for your message of support to our newest laboratory. As what the Secretary said, indeed, MATDEV is a really promising laboratory that could enable collaboration and partnership among industries and the academe. And because of this facility, we will now have a shared facility for 3D printing endeavors. And I'm very excited to know more about it as we go along to our program today. And now, to discuss the event rationale and the main objectives of our gathering for this morning, we have the Chief of the Technological Services Division, Ms. 𝘿𝙚𝙎𝙧𝙩𝙎 to give the event rationale. Give it away, Ms. Nelia.
Okay, to all our participants, guests from the industry, the academe, SUCs, government and private sectors, to our media friends, DOST and ITDI family, and of course, to all our Facebook viewers, a pleasant good morning to everyone. So today we are truly happy that once again we are gathered in this virtual platform in line with this very important event, our Stakeholders Forum on MATDEV, or what we call Materials Development Facility. But before we start with the program proper, it is necessary for us to rationalize the significance of this activity, both for us and for our stakeholders. Generally, this event aims to communicate to you the good news, particularly the breakthrough in the research and development of innovative 3D printing technologies through the establishment of the Center for Additive Manufacturing. Just a while ago, you have heard our dear secretary in his message who have walked us through in every details of the project. Likewise, gave us the possible potentials and outcome of this center to our local industry, probably 5 to 10 years from now. Actually, all these efforts has been an offshoot of the collaboration between our Metals Industry Research and Development Center, or the MIRDC, and the Industrial Technology Development Institute of the Department of Science and Technology, with this intention of enhancing capability of local experts in the field of 3D printing, while also fostering collaboration among the industry, the government, academe, and all our relevant stakeholders in the development of additive manufacturing potentials. This will ensure that all efforts will not be in vain. We should like, we would also like to help our stakeholders through this platform to better understand how government, particularly the DOST, through its agencies like the MIRDC and ITDI, can support the industry through innovative 3D printing technologies and services, and to help promote competitiveness of our local industry. Likewise, understand how our MATDEV facility will be able to contribute to the overall goal of the AMCen program of the DOST. So what do we expect for this morning? Of course, our researchers and experts from the field of material science will be presenting to you the very essence of materials development and prototyping services, which is a very important component of the additive manufacturing. Of course, you will be also be having a virtual tour of the facility, while our participants will be given an opportunity to ask questions, have some clarifications, and probably share some insights on the presentations in today's activity. We also encourage everyone to please participate in our Q&A. Lastly, we believe that government efforts will be in vain if we do not get the interest, commitment, and support from our relevant stakeholders. Since we have already made a notable advancement in terms of science, technology, and innovation through the establishment of our AMCen, now it's the time that we seek your support to make this project through our MATDEV facility worthy and viable by partnering with us and providing us the much sought feedback on how we can better serve our stakeholders. We hope that from this day onward, we may be able to forge partnership with you and other forms of engagement through the service offerings on materials development. So now, just sit back, relax, and enjoy the presentations. Of course, again, we would like to emphasize that we will be more than happy to serve you and to be your partner in the near future. So thank you very much. Keep safe and mabuhay po tayong lahat.
Okay, thank you very much, Ms. 𝘿𝙬𝙙𝙧 of the Technological Services Division for your event rationale. So I hope our participants now have the idea why we are holding this event today. Just like what Ma'am Nelia said, we are looking for partners because we cannot do this alone. ITDI and MIRDC has the tools and the facilities that can help you, but we need you and your ideas in order to make this facility and the products available to the Filipino people. Again, thank you very much, Ma'am Nelia. And now that we had the event rationale, of course, we will introduce you to the organization or the division behind the Materials Development Laboratory. And to give us an introduction about our organization, the Material Science Division, as well as AMCen-MATDEV and its services, we have the OIC and Supervising Science Research Specialist of the Material Science Division, Ms. Josefina R. Silorico. Good morning, ma'am.
Good morning. Thank you, Ms. Meg. Good morning and welcome to my presentation. The following are the topics to be presented. First, an overview of our institute, then followed by the profile, services, and facilities of the Material Science Division. Then, AMCen services and facilities will be discussed. And last but not the least, a very, very short introduction of MATDEV. Next slide, please. ITDI, or Industrial Technology Development Institute, is one of the R&D Institute of the Department of Science and Technology, and it undertakes the following mandate: to undertake multiple disciplinary industrial R&D to generate new technologies, innovation, and knowledge in line with the priority programs of DOST, to provide a variety of technical services and intervention to different stakeholders, especially industry, to improve their productivity, modernize the production sector, and be globally competitive, and to conduct technology transfer of developed technologies for commercialization. Next slide, please. This slide presents the different division of our institute, and here you find five divisions. This slide presents the organizational chart of our institute, and it includes 5 divisions that is in line with the major R&D researches of the Institute, and one of them is the Material Science Division. The Material Science Division, or MSD, spearheads the R&D programs of materials essential to the development of local industry while harnessing the use of locally available resources. Next slide, please. The function of the Material Science Division are as follows: to undertake research and development on material science and engineering, especially in the areas of advanced materials, surface engineering, and special materials. To undertake technology transfer of generated technologies, to provide technical assistance and support services to clients, such as industry and academia, that is related to the division's field of expertise, and to contribute in the planning and implementation of the Institute programs and projects. To perform these functions, the Material Science Division has 3 sections. The Advanced Materials, where R&D on polymers, natural fiber, reinforced nanocomposite, and quantum dots are being undertaken, while the research on ceramics, particularly for water purification and filtration, and mineral processing and utilization for the production of nanomaterials and its application are being undertaken by the Special Materials section, while the Surface Engineering conducts the research on corrosion, surface coatings, and membrane. Next slide, please. The Technical Services of Material Science Division consists of an R&D collaboration with academia, government institution, and industry. Next, it also conducts tests and analysis and use of facilities. Seen in this slide are the list of technical services that are frequently requested in our division, such as elemental analysis by X-ray fluorescent, particle size analysis by dynamic light scattering, as well as preliminary evaluation on one red clay sample. For use of facilities, most commonly requested are the use of our compression molding and our injection molding machine for the processing of plastic materials. Next slide, please. Material Science Division has several laboratories, and there are laboratories for ceramics, laboratories for inorganic materials for upgrading, modification, and processing, laboratory for plastic testing and processing, as well as a materials characterization laboratory. And the following equipment are housed in these laboratories. We have a high temperature furnace that can reach as high as 1600 degrees centigrade, a spray dryer, and a universal testing machine for mechanical strength analysis. Likewise, twin screw, extruder, and compression molding for processing of materials are also housed in this laboratory. Additional laboratories were also established in our division through the help of the DOST Shared Assisted Project, and they are spearheaded by our former Division Chief, Dr. 𝘿𝙊𝙎𝙧-𝙎𝙢, which, by the way, will be one of the resource speakers in this forum. Next slide, please. To develop local expertise in membrane technology, a membrane laboratory was set up in last 2018, and the following fabricating machine was acquired: a fabricating machine for electrospinning, hollow fiber spinning, and a casting machine was acquired to develop different types of membrane, like as electrospand membrane, a hollow fiber membrane, and a flat sheet membrane. Next slide, please. Next. In 2015, a nanotechnology research facility was also established to provide nanotechnology-related technical services and R&D and analytical equipment such as transmission electron microscope, atomic force microscope, and dynamic light scattering for particle size analyzers were housed in this nano lab. Next slide, please. AMCen-MATDEV, or Advanced Device and Material Testing Laboratory, is a national testing laboratory that was established in 2012 and equipped with advanced analytical instruments for failure analysis and materials characterization. Technical service of this laboratory includes surface analysis, imaging and microstructural analysis, compositional analysis, and thermal analysis. Likewise, sample preparation before they undergo this analysis are also being undertaken in this laboratory. With that, they also house advanced analytical equipment such as OJ electron spectroscometer, time of flight secondary ion mass spectrometry, field emission scanning electron microscope. Next slide, please. And recently, as mentioned by Secretary de la Peña, 𝘿𝙊𝙎𝙧, and Director Annabel Briones, one laboratory was again inaugurated, and that is the Materials Development Laboratory, or MATDEV, which is one of the two facilities established under Additive Manufacturing Center. I will not talk about this because the next succeeding resource speaker will give you a detailed presentation about the profile, services, and facilities of MATDEV. With that, I would like to end my presentation and thank you for your attention.
Thank you very much, Ms. Josie Celorico, for your presentation on MSD and its services. Truly, MSD is not just about MATDEV, but it has a lot of facilities that you can offer. I'm sure in one way or another, our industry partners who are here with us today and some people from the academe have been in partners with MSD regarding different endeavors on material science. Again, thank you very much, Ma'am Josie, for your presentation about MSD. And now we will proceed with overview of the AMCen-MATDEV and what this facility is really all about. We will hear from the former chief of the Material Science Division, one of the pillars behind the AMCen-MATDEV project. Let us please welcome Dr. 𝘿𝙊𝙎𝙧-𝙀, former chief of the Material Science Division. Good morning, Ma'am 𝘿𝙊𝙎.
Good morning.
Hi, ma'am.
Can you see my slide?
Yes, ma'am.
Okay, so thank you for that nice introduction. Good morning, everyone. I will be presenting the overview of AMCen-MATDEV. Welcome to the Advanced Manufacturing Center, or AMCen, of the Department of Science and Technology. This project is jointly implemented by ITDI and MIRDC. Advanced manufacturing or 3D printing techniques continue to evolve quickly, and the establishment of the Advanced Additive Manufacturing Center in the Philippines is at the forefront of this technological advancement. The program is composed of two projects, such as the development of multiple materials platform for additive manufacturing, or MATDEV, implemented by ITDI, and the research on rapid and advanced prototyping for product innovation and development using additive manufacturing, or rapid ADMATEC, implemented by MIRDC. The general objective of the program is to establish a national center of excellence in additive manufacturing, or AM, with the following objectives. First is to establish the Philippine Center for Additive Manufacturing as the premier hub for developing the next generation of manufacturing engineers in conjunction with the industry partners using various materials such as polymers, ceramics, metals, and multiple materials for 3D printing. Next is to be the nation's leading research center in 3D printing and achieve prominent and outstanding breakthroughs in the research and development of innovative 3D printing technologies, processes, and materials. Third is to enhance our capability in the design, materials development from local sources, testing, and prototyping of products for additive manufacturing. Fourth is to foster effective collaborations among industry, government, academe, and nonprofit organizations to ensure the continued development of additive manufacturing potentials. The following services will be offered by the center. We have training services on design softwares, equipment operation of various 3D printing platforms, and materials development, among others. We will also offer materials R&D using indigenous sources, prototyping, materials and product testing and evaluation, R&D collaborations with the academe, industry, government, and private entities, design concepts, policy standards development, and education formation, or for AM to be part of the curriculum. This is how AMCen works. MATDEV handles the materials processing, characterization, design and product development, and prototyping and performance testing. The facilities involved here will be discussed in detail by our speakers, Engineer 𝘿𝙊𝙎𝙧 and 𝘿𝙚𝙥𝙖𝙧𝙀. While Rapid ADMATEC handles the following: reverse engineering and characterization, 3D CAM modeling, optimization, 3D printing in large scale or big builds, post-processing and validating or characterization. Shown in the photos are the equipment used for each step. The AMCen main facility is located at the MIRDC compound or at the south gate of DOST, while the MATDEV laboratory is located within the ITDI compound and is now on full operation at the MSD building. In the year 2018, ITDI and the Metals Industry Research and Development Center initiated the Advanced Additive Manufacturing R&D program, which was approved for implementation in January of 2019. So under this program are the two projects, which is the MATDEV and the Rapid ADMATEC. Various activities were held jointly by ITDI and MIRDC under this program, such as the Stakeholders Forum, the Additive Manufacturing Summit, the groundbreaking ceremony of the AMCen, the Philippine Additive Manufacturing Day, and our very own MATDEV laboratory inauguration last December 22 of 2020. One of the MATDEV's objectives is to develop the competency of the technical staff on design, materials development from local sources, and testing for additive manufacturing applications. The MATDEV team is composed of licensed engineers and chemists in various fields of disciplines, 6 of which have PhD degrees, 14 with master's degrees, and 10 with bachelor's degrees obtained here and abroad. Foreign training at Nanyang Technological University or NTU of Singapore, Singapore Center for 3D Printing, and Singapore University of Technology and Design or SUTD, and Case Western Reserve University in Cleveland, Ohio, USA, on the various aspects of additive manufacturing, and these were attended by the MATDEV technical staff. Benchmarking activities were also conducted at the National University of Singapore and the Oak Ridge National Laboratory at Knoxville, Tennessee, USA. Moreover, the MATDEV team underwent various local trainings on the operation of the different additive manufacturing equipment. Despite the pandemic, they were doing the training online, and on special cases, we also had a face-to-face training. Furthermore, the COVID-19 pandemic has greatly affected our country, and MATDEV responded in addressing the needs of our frontliners and COVID-19 patients through 3D printing technology. Currently, MATDEV team had distributed PPEs and medical devices or parts to over 50 hospitals in Metro Manila and nearby cities, and this is still an ongoing activity. In line with the policy development in our country, DOST-ITDI has initiated the establishment of the Technical Committee on Additive Manufacturing in coordination with the Bureau of Philippine Standards, Department of Trade and Industry. So the first technical committee meeting, or TC88, on additive manufacturing was held last March 9 of 2020 and was attended by around 35 participants from industry, academe, research institutes, pub labs, and government agencies. 5 working groups were formed to adopt the international standards for additive manufacturing to address the concerns of the manufacturing industries, resolve research needs, and identify gaps related to additive manufacturing. 2 standards were approved for circulation by the technical committee, standards on terminology and on qualifying machine operators of laser metal powder bed fusion machine and equipment used for the aerospace industry. To date, we already endorsed 2 draft Philippine National Standards for publication as our Philippine National Standards on Additive Manufacturing. The committee will be reviewing 28 standards for adoption in the country this year, 2021. The Materials Development Laboratory, or MATDEV, was inaugurated last December 22, 2020. It consists of FDM laboratory, post-processing laboratory, chemistry lab, materials characterization lab, 3D printing R&D lab, and spheroidizing laboratory. MATDEV is ready to provide services to various stakeholders in the industry, academe, and government sectors. Its commitment to deliver innovative solutions to support the manufacturing industries by the fusion of nanotechnology and additive manufacturing using our developed nanomaterials to produce filaments. The local materials developed will be cheaper and had improved properties and performance as compared to the imported material. MATDEV will create different possibilities such as replacements of human parts, infrastructures that are custom-made, among others. The facility will greatly contribute for the progress of the country and to be the nation's leading R&D center for 3D printing. This is the MATDEV team. We are ready to serve you. MATDEV has limitless possibilities in 3D printing. We are the solution to your 3D printing needs. We are open in this new normal. With that, thank you very much.
Thank you very much, Dr. Basilia, for your presentation on the overview of AMCen-MATDEV. Again, a virtual round of applause for Dr. Basilia and, of course, the MATDEV team for their painstaking efforts in establishing this facility to make 3D printing possible in the country. So again, this facility enables shared facility for everyone who's interested, especially the industry and the academe, to have a common facility for 3D printing and additive manufacturing of various materials that can be useful for every Filipino. Again, thank you very much, and thank you to the MATDEV team for making this possible. Now that we've heard from the former chief, Dr. Basilia, we will now delve in to the additive manufacturing and its different applications. We will now hear from one of the members of the MATDEV team, none other than Engineer Marianito T. Margarito, Senior Science Research Specialist of the Material Science Division. Good morning, sir.
Good morning, everyone. So this is very overwhelming. I saw the number of participants is around almost 300. And yeah, given this pandemic, this is some of the benefits of it. We reach out to various locations in the Philippines. So today, I'd like to take this opportunity to thank the Department of Science and Technology for the support for this project and other projects that we are implementing at our institute. And for this, I will be presenting the applications of the additive manufacturing. So you know that additive manufacturing was also called 3D printing before rapid prototyping, and now they can also refer to it as digital manufacturing. So basically, the application of additive manufacturing is limited by the materials. And if you want to 3D print something, you must find a material that is 3D printable. So the applications need to be identified, and we can, through MATDEV, we can develop the materials that we can use for 3D printing this stuff that you want to use or 3D print. So 3D printing or application of 3D printing depends on materials, and there are three basically classification of the applications of additive manufacturing. First is the design, second is engineering, analysis, and planning, manufacturing, and tooling. So for the design, you need to do some design by validation, or sometimes you just need to see something out of a drawing from the CAD or an ultrasound. So like here shown in this picture, they use additive or 3D printing for some blind, someone that is blind to see the ultrasound of her baby on her womb. So it's very useful for them, given that that the 3D printing can accurately 3D print the materials or the ultrasound of the baby. So if they touch it, they will see it in such a way to before it was be born. And here, one advantage of additive manufacturing is design freedom. So complexity is free. So in many cases, like for example, in this application, so they make use of 3D printing. If you 3D print the usual things, you cannot take advantage of the whole 3D printing process. So what you may do is to reduce the design or do some regenerative design through artificial intelligence. So from this, they reduce the weight by about 40% and make it stronger by 20%. So from 8 components into 1 part, so preventing failure on various connections or the screw that is that's the cause of the failure of this particular part. And they use 3D printing for commercial and sometimes in movies, so for the effects, and they use various materials with a colorful effect on the 3D printed products. Yeah, another another application of 3D printing. So I'm discussing some applications that are interesting, and the application of 3D printing is not limited to, is limited by your imagination. So if you have think of some applications, that's also possible. That is very, very possible. And one interesting application of 3D printing is in the mock-up, pre-production, or 3D printing of obsolete parts. So this is very useful for before launching a product that is functional in nature. And for obsolete parts, some of the assets, like in the government military of the Philippines, sometimes they have obsolete assets because the part is not available anymore or it's obsolete. But through 3D printing, we can 3D print this part and make these assets useful again, and perhaps prevent some of the accidents, like the helicopter incidents that happens for the military because of the obsolete parts that is not available, since these assets were no longer in production. So another interesting application of 3D printing is in food. So in other countries, they have, you can see here on the conventional food hospital on the left. So imagine a sick person being given this. So they would opt for this kind of on the 3D printed puree food, which you can customize the appearance and also the nutrition for the requirement of the patient. So we can facilitate healing and recuperation of the patient with 3D printed puree food. So another application is in building and construction. So this is advantages of this are zero waste construction, so time and cost reduction, and supports unusual design. So in Dubai, they have 3D printed buildings. This one is the largest in the world, 3D printed around 640 square meter. And yeah, and they plan to construct building 25% of the building in Dubai using 3D printing. So another application is in the planning and simulation of complex surgery. Actually, this is already done at the UPPGH. So there's a surgeon as Dr. Bondoc that we also are part of our steering committee of the AMCen. And he, before the conceptualization of the program, he is already using 3D printing to plan surgery. So it's possible that to to make the surgery fast and enable recuperation of the patient, and enabling the precise model of the based on CT scan, and that they can move better and maybe reduce errors in the human error in the surgery. And another application is in dentistry. So imagine the crowns and bridges and also the dentures. Sometimes it takes sometimes for the usual conventional process to give this or to make this part available. Since this is a highly customized, so they will make a mold out of your jaw. But with 3D printing, perhaps you can do this within the day. So within 24 hours, or you can have these parts already available. So another customized implants and prosthesis, and these are some of the patient could require these parts, and yeah, and through 3D printing we can customize these parts according to the needs of that will fit on the parts of the patient, and we can introduce some porous structure where we can facilitate the growth of cell. And we are visioning to have this 3D printing in every barangay that could serve those people with amputated limbs or hands, that could 3D print these prosthetics on their part, so they will have this convenience on their part. So another application is similar to the previous one, is tissue engineering scaffold. So it was also mentioned by Secretary that you can 3D print body parts by 3D printing cells or 3D printing scaffolds where you can grow the cells. So another interesting application is for wildlife conservation, and there's this Pembient. This is a startup company that fabricates wildlife products. This is a rhino horn, and this is have illegal trades, and they have black market for that. And through 3D printing, they have imitated this kind of exactly indistinguishable from the real one. And through biotechnology and 3D printing, and with this, they can reduce the price of these products, and reduce and also suppress or discourage the black market or illegal trade of this wildlife product, thereby conserving the endangered species. So another application is in drug delivery. We can customize this drug delivery device using 3D printing by making the center porous where we can hold the drug, and the string that surrounds it is a semi-permeable part, or which have small pores and control the diffusion of the drug. And the power of 3D printing was manifested during the pandemic. So here are the items that we have 3D printed, as was mentioned by our previous speakers. And I would like to emphasize on this e-relief fund. This product is not really needed before, but there was some experience by those the frontliners, medical frontliners, even in China, where the pandemic starts. They have some injuries caused by long-term wearing of the face mask or PPE. So actually, this one of the design created for this one was made by a grade schooler. So imagine, the 3D printing is not only for adults. Maybe those in some countries they already include it in the curriculum, and some students in the grade school already are using 3D printing for their academic requirement. And it will, since it was mentioned before that the the peak of innovation is around before 10 years of age, so we can make utilize this 3D printing to enhance the innovation or creativity of a child from childhood to, so we can sustain it up to the latter stage of their development. So these are other 3D printed items. We have the prototypes of doorknob handles, venturable aero chamber prototype, and we have the face shield. So some of these were tested in some hospitals in the Metro Manila. So also the 3D printing community, so given the lockdown caused by this pandemic, they also have share of this innovations on like a 3D printed swab and some parts of the respirators and customizable masks. And yeah, so given that, it's not those that I presented are not the only the applications of 3D printing. Actually, there are many applications of 3D printing you can think of. Just you can think of it, and this technology is very disruptive. You can disrupt the supply chain. You can disrupt the applications, and yeah, this is very useful. And here you can see now here is the hype cycle. This is an iconic Gartner hype cycle for technology. So initially there's a new technology, there's a increase in expectations of the technology, interest, and that comes to a peak. And then once those interests try this technology, they have encountered these problems, and or the investment on this technology is very high. So it gradually declines, and research will come in to address these problems like in the technology. So basically on the right side are this mature technology that are gaining momentum for its commercial viability. So at the end of this spectrum is the 3D printing service bureaus, where AMCen is or the Additive Manufacturing Center uh, be will play a role in providing 3D printing services in the country. So with this, with the development of materials or the promotion of 3D printing in the country, we are also adopting standards to the Bureau of Philippine Standards to ensure performance of these 3D printed components or applications of these 3D printed parts. And lastly, thank you everyone. I would like to take this opportunity. So in October 28 and 29, we'll be planning to hold the International Conference on Additive Manufacturing, and that will be hosted by the AMCen. And we'll see you, and thank you very much for your attention. That's all.
Thank you very much, Engineer Margarito, for discussing the many interesting uses and wonders of 3D printing. Indeed, we are on board Industry 4.0, and the possibilities for additive manufacturing are endless. And indeed, imagination is our only limit. Again, a virtual applause for Engineer Margarito for his very interesting presentation. And I can see that we are already receiving questions here in Zoom. And
can I speak?
Sure, sir.
Margarita.
Okay, sir.
So I just would like to thank our resource persons, our organizers from the Industrial Technology Development Institute for holding this forum. And I also would like to express my appreciation for all those who participated in this forum. I was reading the questions, and I was saying to myself that maybe those who have very concrete projects in mind can already discuss with our MATDEV team, okay, in addition to the chat questions. Then I would also like to mention that I was so happy to hear that one of the partners that you have in the MATDEV is Dr. Bundok. I have known him for a long time, and he was one of those who has been very active in coming up with innovations, and new equipment, new materials at the UP College of Medicine, and so we can benefit from his long experience. And I also would like to mention that hopefully we can get more people interested in pursuing advanced degrees in the area of material science, materials development, and I foresee that in the future, the Industrial Technology Development Institute and the 𝘿𝙦dev will have a role to play in having these programs for the advancement of our human resources in the area. So this is, I have to leave now because I have to be in Cebu virtually in the next few minutes. Thank you very much.
Thank you po, Secretary FTP.
Okay, again, thank you very much, Secretary Fortunato T. de la Peña, for gracing our event. Thank you very much for your support, as always. And okay, thank you again. So I can see that we are already receiving questions, and we will acknowledge all the questions once the speaker are done with their respective presentations for purposes of time management. I can see that we are ahead of schedule, so we can accommodate more questions for you. You can continue typing in your questions via Zoom chat, and we will answer them later on in the Q&A. Again, thank you very much for your support and attention. And now that we've heard the applications of 3D printing, we will now give you a sneak peek of the extensive facilities being offered by 𝘿𝙦dev Laboratory. To discuss the different 𝘿𝙦dev facilities, may I please call on Engineer Joanne C., SRS2 of the Material Science Division, for her presentation. Give it away, Ma'am Joanne.
Good morning. So let me just share my slides. So good morning, everyone. Good morning to our dear stakeholders, to Usec Gav, to Dr. Briones, and to my fellow speakers. So I'm here to present to you to share with you the available facility at 𝘿𝙦dev. So to our dear stakeholders, we hope that you may match some of your technology and research development requirements with 𝘿𝙦dev after hearing all the presentations. But first, let us review the generic additive manufacturing process. So it begins with the generation of a computer-aided design. And this CAD file should be converted into an STL file or the standard tessellation language. Now, this STL file will be converted into a G-code using your slicer, depending on the 3D printer that will be used. I believe that 3D printer now is just like an ordinary appliance. Any household can acquire a 3D printer. And so after having your CAD file, your STL file, you can now start building your part using your 3D printer. And after printing, you may need some post-processing removal of the support materials of your 3D printer. And for 𝘿𝙦dev facility, the best thing that the best thing that 𝘿𝙦dev have is that aside from the design and simulation software and the 3D printers, our facility have the processing and the characterization equipment for the 3D printing materials, because that is the forte of 𝘿𝙦dev facility, the development of the 3D printing materials. So as I said a while ago, our center have the software, and we also have the Artex Spider scanner for scanning small objects. So yes, the first thing that we need is to have an STL file. And we actually have three ways in obtaining an STL file. We can either download some free files online, or you can design your own, you can generate your own STL file using softwares like SolidWorks. And the third way is for you to scan your object and edit it, improve it using SolidWorks. Now, aside from the SolidWorks, we also have simulation software from MSc that will help you to simulate the structural behavior of your given formulations. Say you have limited materials and you would like to simulate what will be the structural behavior of your composite formulations. Now, after you have the STL file, you can now proceed to 3D printing. And MATDEV have the following AM technologies for your printing needs. We have several desktop printers, with material extrusion, using material extrusion, vat polymerization, and powder bed fusion printers. So for materials extrusion, this is just likened to the principle of the glue gun, where you melt the plastic, and that plastic you can deposit it in the metal plastic can be deposited in the build plate. For vat polymerization, it utilizes resin, photopolymer resin, that cures when exposed to light. And for powder bed fusion, it utilizes polymer powders that is being fused according to the design of your, according to the STL design that you have. So moving to our materials extrusion printers, we have three types. One is the low temp printers that can print low temperature polymers, and we have the Ultimaker S5 and the Creality Ender Pro. Now we also have the MarkForge Mark II. So this is also a low temperature printer, a fused fabrication filament, continuous fiber reinforcement. And the unique part about this printer is that the filaments here is reinforced with fibers. You can use, it can be reinforced with carbon fiber, fiberglass, and Kevlar. So this printer and the one that I mentioned ago can print polymers with a temperature of 280 degrees Celsius. Now moving to the last last type of less available printer under the materials extrusion is the Intensys FunMat Pro. So this printer can process high temperature filaments in addition to the regular filaments. So this printer can print with a maximum temperature of 500 degrees Celsius. It can process several high temperature filaments such as polyether ketone, polyether ether ketone or PEEK, and polyether ketone ketone or PEKK, and among others. Now moving to the next available printer at MATDEV, we have the Formlabs Form 2, categorized under the vat polymerization. And the advantage of using this printer is that you can produce airtight and watertight printed parts. Moving to the next desktop printer, we have the Sinterit Liza Pro. This is a selective laser sintering printer and allows you to print parts without the support material. So this is critical, especially when you are printing parts that have yung mga hollow parts and small diameters inside, because you won't be needing anymore the support materials. And this printer can process polymer powders like nylon and some other general purpose TPU materials and rubber materials. Now, as I said a while ago, the forte of this laboratory is developing 3D printing materials for several printers. That's why yung mga printers namin desktop lang muna, kasi MIRDC houses the desktop and the big equipment. They have it. So now going back to the 3D printing materials, we need polymer filaments, we need metal powders, and we need ceramic powders. And we are happy to tell you that MATDEV have the equipment to process and characterize those 3D printing materials. We have several 3D filament makers that can process filaments of up to 450 degrees Celsius. We can make composite filaments. And the best thing about this filament maker is that we produce yung uniform filaments. This is very critical para hindi magbabara yung ating mga FDM printers. Now, for grinding metals or hard materials, medium hard, soft, brittle, elastic, or fibrous materials, we have several milling machines. And one of these is the 𝘿𝙊𝙎𝙧 cryo mill. Another one is the 𝘿𝙊𝙎𝙬 ball mill. And we are very happy to tell you that MATDEV houses the very first spray dicer in the Philippines and even in ASEAN region. So this equipment improves the metal and ceramic powder flowability. Kahit nga yung residue metal powder from our metal printers, pwedeng i-recycle using this equipment. Now, moving on, aside from the processing equipment, we have our laboratory houses also some characterization equipment, including digital microscope and dynamic mechanical analyzer. And MATDEV laboratory is complemented by other ITDI laboratories. We have access to the several processing equipment and analytical equipment from the DOST-ITDI Nano Lab. And this was already explained by Ma'am Josie a while ago. So we have the two-roll mill, we have twin screw extruders, we have TEM. And aside from that, we are also complemented. We have access to ADMATEL for analytical tools that may require VSEM or TOF-SIMS or TMA or differential scanning calorimetry and others, among others. So in summary, MATDEV houses design and simulation softwares. We have the 3D printers, we have processing and characterization materials for the development of your 3D printing materials. So again, we invite everyone, we invite those who are interested, come, let us, you may talk with us and discuss with us the research needs with regards to 3D printing materials. And again, thank you. This ends my presentation. Thank you.
Thank you very much, Engineer C, for walking us through the process of 3D printing and giving us a sneak peek of the many extensive facilities of MATDEV. I am sure that our participants are very excited to know how to avail them and how to collaborate with you. Again, we will answer questions after our one last presentation and before our virtual tour. And We still have another presentation in the pipeline, and to give us an idea of the pricing, modes of engagement through 𝘿𝙤𝙤 Laboratory, and its services, we will now hear from Mr. 𝘿𝙚𝙤𝙧𝙯, the Senior Science Specialist of the Material Science Division. Good morning, Sir Carlo.
Okay, good morning, Meg. Thank you very much. And again, thank you very much. I would like to thank everyone for joining us today in this Stakeholders Forum. And I am sure that the previous presentations have piqued your interest in additive manufacturing, and probably you have a lot of projects already in mind. So we at 𝘿𝙤 would like to be that link, that will help you bring those innovative ideas into something that you can see, touch, examine, and further improve. With the facilities just mentioned, so 𝘿𝙤 offers a wide array of services from design to prototyping, characterization, and even services that offers a wider scope like R&D collaborations and trainings. Okay, so these are, again, the major services of 𝘿𝙤. So for design optimization, 𝘿𝙤, previous slide, please. For design optimization, so 𝘿𝙤 has acquired softwares that can help turn your intricate designs or concepts into 3D printable objects. So this design can then be further improved to achieve the desired function or property. Another indispensable tool that can hasten design improvement is 𝘿𝙤's 3D scanner. Our Arctex Space Spider is highly suitable for capturing small objects, complex geometries, sharp edges, thin ribs, or intricate details of large industrial objects in high resolution. The tentative rates indicated here are for the objects with different diagonal lengths. Okay, next slide. For parts prototyping, 𝘿𝙤 does not simply offer 3D printing services, but also some of the needed tools for material preparation. We have two types of ball mills, for example, that can produce powders depending on your material and processing requirements. For the processing of metal powders, 𝘿𝙤 has the technospherodizer, which is important for applications or methods that require spherical powders to ensure a dense part or a defect-free layers. Having a suitable 3D printable material is also a challenging yet rewarding aspect of prototyping. One important stage in prototyping, especially those that include product development, is the preparation of filaments for fused deposition modeling. 𝘿𝙤 has different types of filament makers like the 3DEVO Precision 350, which can be used for high-quality mass production. We also have the 3DEVO Composer that can be used for material mixing and experimentation, an example of which is the production of filaments from PLA containing different local reinforcements. For plastic materials that need initial size reduction, 𝘿𝙤 also offers its plastic shredder. So this is important. This is an important tool, especially for processing recycled plastics. Of course, part prototyping will not be rapid without 3D printing. So 𝘿𝙤 houses a good number of 3D printers that caters to different materials or application requirements. So one of the commonly used FDM printers at 𝘿𝙤 is this Ultimaker S5. Our 3D printing services, and this service is reasonably priced and already includes the materials such as PLA or ABS and the use of the printer for 8 hours. So if you need to 3D print high-performance polymers such as PEEK or PEI, which can be used as a substitute for some metals, or even custom-made implants, so 𝘿𝙤 has this Intamsys FanMat Pro that can reach nozzle temperatures of up to 500 degrees Celsius. Shown in your screen are the tentative amounts for an 8-hour use using the indicated material types. So Markforged Mark II will be your choice for 3D printing using continuous fiber reinforcements such as microcarbon field nylon called Onyx, containing continuous carbon fiber or Kevlar or fiberglass. So the choice of material will depend whether, for example, you want your material to be highly impact resistant or ultra high strength, or even perform well in even high temperature environments. So aside from FDM, MATDEV also has 3D printers that make use of other technologies. One of which is the Formlabs Form 2 that makes use of SLA or stereolithography. If this is your desired technique, you may choose from the different material types shown in this slide. So another 3D printing technique makes use of powder bed fusion technology, which offers its own unique advantages, like, for example, printing movable parts and working mechanisms at one go. And as with some of the specialized MATDEV equipment mentioned earlier, it is recommended that you discuss your processing requirements with our MATDEV staff to determine the appropriate approach. At MATDEV, we also believe that continuous material improvement involves analysis of both the raw materials and the finished products. That is why we also offer different analytical services to ensure the quality of materials. One of these tools is the digital microscope. We offer both 2D and 3D imaging, which may also include measurements, such as length, area, and many more. The DMA, as mentioned earlier, is a special tool to determine the viscoelastic properties of your material, especially polymers. So DMA can be used to mimic operating conditions of the material that can be used to predict how the material will perform. So at present, we offer determination of glass transition temperatures at both positive and negative temperatures. As also mentioned in the previous presentations, what is special about MATDEV is its connection to other ITDI or DOST laboratories, which means that you have almost everything you need. So from material preparation up to product analysis in just one place. So I would like to point out, for example, that aside from the filament makers that we have at MATDEV, we also offer the use of single screw and twin screw extruders at the Material Science Division. We also have a whole bunch of other technical services, such as elemental analysis, particle size analysis, surface roughness, and TEM imaging, all available at the Nano Laboratory. So again, MATDEV is also open for long-term engagements, such as R&D collaborations, contract research, or even trainings. So it is our desire that AMCen and MATDEV in particular not only become a service provider, but also, but really a partner, a collaborator in your additive manufacturing endeavors. So again, thank you very much, and we hope to hear from you later. So thank you.
Thank you very much, Sir Carlo, for your brief presentation on MATDEV's different services. I am sure that our participants are very excited to be partners with you now that they've seen your extensive array of different facilities, and to think that other facilities there are the first here in the Philippines. So again, MATDEV Laboratory is situated here in DOST-ITDI's office in Bicutan. So we are looking forward to our future collaborations with you. And that ends our presentations for today. And now that you've heard about the additive manufacturing and its applications, you had an overview of its facilities and services. As much as we would like to invite you here, all of you here in Bicutan, unfortunately, we are right in the pandemic. So we will just bring MATDEV to you. So we will have first a virtual tour of the MATDEV facility before we proceed with the Q&A session. So please focus your attention on the screen, and we will have a virtual tour of the MATDEV facility and its services. Enjoy.
Hi, I'm Maris. The Composer 350 and 450 are compact Tesla filament makers to create your own professional materials. The Composer 350 can handle up to 350 temperature, so which means it's relatively used for polylactic acid or PLA and ABS or any other low temperature thermoplastic materials. On the other hand, we have the 450 and can process PEK, PETG, PEK, PET or PETG, thermoplastic polyurethane, and thermoplastic elastomer. So actually our 3D Devo Composer 350 and 450, it has mixing parameters, which you can add more materials and additives. So it is also designed for effortless operation. It is a very simple interface, automatic net spooling, and industrial grade components. All packed inside a compact silver powder-coated interior, something like this one, and the powder to create your own customized 3D printing filament, now at your own fingertips. The Precision 350 is a compact tabletop single screw extruder also that enables quality extrusion of consumer materials such as polylactic acid, acrylobutadiene styrene or ABS. It's also possible for use for polyethylene and other low temperature. And this 3D precision screw, it offers a faster extrusion speed and steady filament flow. And as a result, more precise filament diameter we can produce here. It includes a simple interface and presents to make it accessible to everyone. Equipped with the next generation automatic net spooling, we have the spooling here. This prevents downtime during printing. Built in with the strong durable components, a long productive lifetime is assured for this particular 3D Devo Precision 350.
Hi, I'm Mark. This year, the shredded shredder has twin capabilities of a shredder and a granulator, together processing as much as 5 kilograms of material per hour. Old plastics can be converted into high-quality 3D printing granules of any desired size in just one run. Designed for effortless operation, Shredded features accessible compartments that facilitate cleaning, material changing, and filter screen replacement of our custom grain sizes.
Hi, I'm Alvin, and this is the Creality Ender 3 Pro. It is an affordable fused deposition modeling or FDM 3D printer which provides a decent build volume, magnetic bed, a power recovery mode, and a tight filament pathway that makes it easier to work with flexible materials. Common thermoplastic filaments such as PLA, wood composite, and TPU can be printed using this machine.
Hi, I'm Buds, and this is Ultimaker S5. It's also an FDM type 3D printer that uses filament extrusion technology. In here, a thermoplastic filament material such as polylactic acid and ABS is extruded through a nozzle and onto a build plate. The nozzle follows a predetermined path and extrudes the material layer by layer. Ultimaker is distinguished for having a dual extruder feature.
Hi, I'm Marlo. This is the FDM printer Markforged Mark II. Markforged Mark II is a special type 3D printer known for its fused filament fabrication or FFF and continuous fiber reinforcement or CFR. It uses microcarbon fiber filled with nylon for high-strength material. Aside from carbon fiber, it also supports other fibers such as Kevlar, fiberglass, and high-strength, high-temperature fiberglass.
Hi, I'm MM. This is the Intemsys SpanMat Pro 410. This is also an FDM type 3D printer, can be used for the printing of high performance and engineering materials such as PEEK and TEI because of its high temperature dual extruder that can reach up to 500 degrees centigrade.
Next is the Selective Laser Sintering Lab, or SLS Lab. Come on, let's get inside.
Parts, PCBs, keys, coins, or even human parts. It offers new options for reverse engineering, quality control, product design, and manufacturing.
Let us now visit the Characterization Laboratory.
Hi, I'm Josie. I'm presenting to you the Hitachi DMA 7100. The Dynamic Mechanical Analyzer, or DMA, is used to characterize the viscoelastic behavior of polymers. A sinusoidal stress is applied and the strain in the materials is measured, allowing one to determine the storage and the loss moduli. The temperature of the sample or the frequency of the stress are often varied, leading to variation in the moduli. This approach can be used to locate the glass transition temperature of the material, as well as to identify transitions corresponding to other molecular motions.
Hi, I'm Lumen, and this is our digital microscope VHS 7000 by Keyence. Keyence VHS 7000 is a digital microscope with a large depth of field and advanced measurement capabilities for inspection and failure analysis. It was developed to improve microscopic observation through the use of adaptive lighting and focusing. It enables observation methods and three-dimensional analysis. Its magnification power can reach up to 2,000 times. The multi-lighting function enables accurate observation of previously unseen surface details such as minute cracks or defects. Real-time depth composition enables the sample is always in focus and the
Planetary ball mills are used whenever the highest degree of fineness is required. Apart from the classical mixing and size reduction processes, the mills are also capable of colloidal grinding and mechanical alloying. The extremely high centrifugal forces of NEAL result in a very high pulverization energy and therefore shorter grinding time. This PN200 is a very convenient benchtop model with 2 grinding stations, which can process familiar additive materials such as alloys, bentonite, bones, carbon fibers, cellulose, ceramics, clay, mineral, glass, limestone, wood, and
Through AMCen, various stakeholders can leverage on these tremendous potentials of additive manufacturing to usher breakthroughs in key areas such as electronics, aerospace, agriculture, pharmaceutical and healthcare, automotive, and consumer products. Imagine it, print it. Beyond the conventional, AMCen-MATDEV.
Welcome to MATDEV, your partner in design, characterization, development, and testing of local materials for your additive manufacturing needs. Again, a virtual applause for the AMCen-MATDEV team for the development of this amazing laboratory that ITDI now has. Thank you very much for that amazing presentation once again. And now we will proceed with the most exciting part of our program. And I have a lot of questions right now here in Zoom. And of course, we will first request our speakers to please turn on their video so that we can properly acknowledge the questions. And I will read them to you since we have a lot of questions already. As of this moment, we now have 14 questions in the pipeline. So we have a lot of time to answer this. And I will start with the first question given by from NRTDC of the Philippine Navy, Mr. 𝘿𝙊𝙎𝙏-𝙬𝙐. So our moderators ready? Okay, I can see that Engineer MM is here, Sir Carlo, Engineer C, Doc Bless. Hello, good morning po. And everyone is here, so we can start with our Q&A portion. So the first question is, may I verify if MATDEV already developed a mechanical ventilator? Does it require FDA approval, like the face mask? So anybody can answer. Raise hand na lang po siguro. So I can acknowledge who wants to answer this question. Approved na po ba ang mechanical ventilator ng MATDEV? Yes, Ma'am Joanne.
So I'd like to answer that question. For the mechanical ventilator and the face mask, so of course it requires FDA approval, and unfortunately, yung ating printing, the MATDEV activities was only limited to the initial prototyping. Now that was to just to test yung ating capability to do that. And along sa development namin, kasi yung sa first activities, during the activities kasi nagkaroon na rin naman na kasi ng mga, kumbaga, separate na mga projects under Fisher na talaga nagde-develop na, dedicated talaga sa pag-develop ng mechanical ventilators. And there are mga several tawag dito na mga steps to consider, maraming designs. And we have learned from the Society of the Pulmonary PC, yung society ng mga the pulmonary doctors, na yung kapag nagde-develop tayo ng mga ventilators, it is essential na regulated yung air, na yung output air ng ating ventilators. So yun, limited lang tayo sa prototyping.
Okay, thank you very much, Engineer C, for that answer. Again, MATDEV, AMCen has two different projects. The first one is under MIRDC, or the Rapid AdmaTech, and MATDEV, on the other hand, is focused on the design, characterization, and development of local materials. So thank you for that question, sir. Okay, so we proceed now to the second question from Ms. Annabel Surara of the Eagle Broadcasting Corporation. Paano makaka-avail ng services, halimbawa sa ospital? Ano ang proseso? So perhaps Ma'am Annabel is asking for how did the hospitals from the metro requested for assistance sa MATDEV? So what is the process? Can answer perhaps Sir Engineer MM. How did you how did the hospitals contact you?
Yeah, before during the pandemic, so nagkaroon ng lockdown, and we are staying in dun sa facility, and we're contacting hospital before just to have our service, kasi hindi pa known yung MATDEV noon, no. So and we have this facility, and some of the hospital have this requirement on PPEs, filters. So kami phone brigade. So parang ganun yung nangyari. So initially parang ma-test lang namin yung capability. So we called up UST Hospital, PCMC, and others hospital na we offer the services for free by then, because meron ng need. There's a need arises, and the 3D printing community all around the world have this kind of parang initiative. So may mga needs like yung sa Italy, may parts ng ventilator na needed, and nagkaroon ng stoppage ng production or closure, lockdown. So they tried 3D printing, and it was very useful. Yun nga lang, they cannot get certificate pa, no? Parang and there's a problem on the copyright, pero inalaw naman ng manufacturer, so they have used it, and kasi there's an immediate need, and 3D printing is a technology that can meet this requirement at that time. So ganun po yung nangyari. But for this time, they can write to our institute, our director, for possible pag mag-avail ng services, we have posted our requirements or our rates for the services of MATDEV. And for long-term engagement, we can do some collaboration and agreement, memorandum of agreement para mas magkaroon tayo ng magandang output dun sa gusto nating i-avail na service for development ng materials for specific application.
Okay, thank you very much, sir. So again, MATDEV is very open for collaborations, and if you're up for long-term engagements, of course, you can write a letter to our director so that we can forge our partnership with MATDEV and possible hospitals that are in need of 3D printing services. Thank you very much for your question, Ms. 𝘿𝙊𝙎𝙏. And we have our third question from the region. DOST-9, Sir Aris Moratalia. May we know the types of filaments already produced by MATDEV? The types of filaments that you already developed, so perhaps...
I'll answer that.
Please.
No? Is it possible na share ko lang slides na aming
Sure, sir. Go ahead.
So
he will share a slide.
So ito yung filament na na-develop namin. So these are the possible applications. Yan po. Yan. So yan po yung mga so far na-develop namin filaments. And this one. So we also have developed filaments that like this one, yung wood floor. No? So kung makikita ninyo, it looks like wood. So you can, with this, you can 3D print wood furniture. But limited nga lang yung ating build volume or yung size na mapiprint. So ito po yung mga na-develop natin.
Okay, sir, I guess he has a follow-up question here. Is there a price if one wants to avail these types of filaments? Do you price this? Do you sell this on the market?
So far, hindi pa siya. So, we would like to patent it first in application. And we would parang mag-engage ng adapter to produce this kind of filament. Kasi mas production na siya. If there's a demand and if there's a demand for this filament, we can have some cooperator or collaborator to produce this filament and have the technology transfer to them. And if they're the first one, they can have this parang privilege to market this product on our behalf.
Okay, so that's it. Again, we don't really sell the technologies and the products that the laboratory develops. Again, we look for collaborators who can mass produce these technologies for commercial use. So if you're an interested collaborator or technology adapter, you can again write a letter to our institute. And now we have a fourth question from Mr. Nestor Lim of News Media Nest. What are the requirements in order to be able to use the facilities offered by MATDEV? I guess the one who presented about the facilities or the services, Sir Carlo or Engineer C, can answer.
So maybe I can answer first. Okay,
So,
if they have a particular equipment or test in mind, so they can avail of this service, just like using the usual process that we have. So we have the price, so they contact us and then they can ask for a quotation for that particular service, and then after the agreed period, so we can accommodate the request. But if they want like what Sir Yami mentioned, a long-term engagement that involves some R&D components, then we can proceed with like contract research probably or R&D collaboration. So that will be a different time.
Dr. C, are you going to add to that?
If I may add,
Engineer C.
Yes, it's very easy to communicate with us, just one email, and we are just an email away. So pwede na natin from there we can discuss your requirements or for your your processing requirements and yeah, for the materials. Thank you.
Okay, thank you. Sir MM, please.
Yeah, may I add, in terms of we can accommodate everyone. So wala naman kami specific requirements for the collaborator. We can accommodate students or hobbyists or artists, even artists we can accommodate. Yeah. So if you have a requirement that could be addressed by 3D printing, then it's open to everyone.
Okay, so again, AMCen-MATDEV is available to everyone. Of course, we need your prior appointment before visiting to us so that we can control the amount of people that are visiting our laboratory. Again, thank you very much for your questions. Is there anyone who's going to Laples, please? Okay. Sorry, so we have another question here from Ms. Aguilar of the Philippines Event News TV. What are the advantages and disadvantages of 3D printing? Advantages and disadvantages of additive manufacturing. Are there any disadvantages? Sir MM, please.
So I've discussed in the application. The advantages of 3D printing is design complexity is free. So you can print anything in your mind that limitless yung application. And for other applications, less po yung wastage since additive po siya. Like, unlike po yung sa subtractive na sinasabi, like kung parang naglililok, there's a waste materials that being crafted from the bulk material, so wastage na yan. But for 3D printing, since you add, so less yung wastage na mangyayari. And another, in some cases po, mas mabilis siya in certain application, like for sa mga dentures or sa dental applications, compared sa conventional, we would take days. But if for 3D printing, siguro hours lang or within the day, we can have the item na 3D printed. Ang disadvantages niya is limited lang yung material na pwede natin magamit so far. And yung application is limited with the material. You can also do some, another disadvantages po niya is that yung build volume. So if we want a bigger item to be print, so we need a big printer, and yun po yung mga disadvantages. And so far, yung mga applications niya, may mga trending applications like for printing ng body parts or like kung sa cornea ng sa mata or mga tissue, medyo pa siya, yung technology is hindi pa siya mature, so hindi pa siya applicable, but it's possible to do this application of 3D printing. Yun po.
Okay, sir, since you've mentioned about the body parts, there is a question here from MJ Balaguer of Diaryong Tagalog. My question in the new normal is it possible for the 3D printing of human liver to address the increase of dialysis patient? Is it possible to 3D print a human liver to address the increase of dialysis patients?
So,
3D liver naman po, sir.
So, I just share my slide nun sa hype cycle. So, I think it's possible kasi although limited lang talaga yung sa material. So, if you can see here sa present ko kanina. Yan. So, kung makikita ninyo, yung 3D printing ng human tissue here is medyo nagde-decline yung expectations because probably there's more factors that need to be considered in 3D printing human body parts. Like yung, like for example, sa kidney, medyo marami, you need to know the structures and the type of cells that should be there and how to grow them. So basically, there's a criteria or requirement for the cells na dapat nag-grow siya, and we can print scaffolds for that. So possible na ongoing pa rin yung research on this on this area, and what we don't know, maybe if the development is naging advantageous, we can also 3D print these body parts. But for now, limited pa lang yung mga body parts na napiprint. So, idagdag ko pa lang din kanina sa answer ko for advantages ng 3D printing, you can print highly customized product for individual users. Like yung meron yung hearing aid. So, pag they use 3D printing to have a good fit sa ears ng individual patient. And in some cases, they can, like for example, sa shoes. So, possible na iba-iba yung size ng panat, iba yung kaliwa, iba yung kana. So, minsan yung, like for my case, mas madaling nasisira yung sa right shoe ko kasi iba yung ano. So, same design din siya. So, with 3D printing, you can customize this product to individual use. So, yung isa pang advantage ng 3D printing. And for other applications po, ito po yung mga nagmamature na technology for 3D printing on this right side. So, for this one, ito yung nasa R&D pipeline po, like yung 4D printing, blockchain, yun po. So, yun po yung
Okay, thank you, Engineer Margarito. Yes, Dr. Leslie, you are to add something?
Yes, I would like to add to the question on 3D printing of liver. Yeah, this is a very interesting area of research. In fact, AMCen is going to bioprinting. For now, the 3D printing of liver is at its experimental stage. In fact, countries like Japan, US, Brazil, they are doing 3D printing of liver. And there are aspects that we need to consider the material to be used. This should be biocompatible. Usually they use hydrogel, and it should create an extracellular cell that should be biocompatible. And for now, they are getting cells from the patient to impregnate with a 3D printed liver. And in Japan, they started to use a liver patch, which is being 3D printed. So they start with a patch first and attach it to the patient before they could apply the 3D printed liver fully to the patient. But this area of research is what AMCen-MATDEV is also going into, that is bioprinting of human parts. Because currently experimental studies have been done on 3D printing also of lungs and also of the heart. So there are a lot of R&D that could be done in this area. And we are open for collaboration to those who are interested to start in this type of research. Thank you.
Okay, thank you very much, Dr. 𝘿𝙬-𝙎, for that answer. I hope that answers the question about human body parts. Again, it's a very interesting time that we live in, that we could already manufacture body parts of humans. So, okay, let's proceed to another question from Nestor Lim of News Media Nest. Are you able to support both Autodesk and SolidWorks in designing CAD for 3D printing?
Let me answer the question.
Go ahead, ma'am.
So as of now, MATDEV is equipped with SolidWorks software. So yun pa lang po muna available na software sa facility sa MATDEV laboratory. Yan. Ngayon kasi po yung pinaprocess kasi ng mga printers natin, no, yung naintindihan lang niya na file is STL. Ang kagandahan po kasi sa SolidWorks is that once you design, no, you have your original design in mind and then you put it into drawing using SolidWorks. Ang kagandahan lang sa SolidWorks, yung output file mo could be STL file na kaagad.
Okay, thank you very much, ma'am. We have another question here from Ms. Aguilar. What is the mission or the goal of the AMCen-MATDEV Stakeholders Forum? I guess our chief, Ma'am Nelia, can answer this because she talked about the rationale of this event. So ano nga ba talaga, ma'am, ang goal of this Stakeholders Forum?
Okay, so good morning to everyone. Thank you for asking that question. Actually, masyado po talagang importante itong event na to, why we organize or held this Stakeholders Forum. The very reason for this is for, as mentioned earlier, is for us to communicate to you the good news of what our DOST through our MIRDC and ITDI have done to ensure that this additive manufacturing will be realized here in our country. Of course, this part is the MATDEV part, in which I have also said that this is a very important of the AMCen Additive Manufacturing Center. As the way I understand it, please, MSD team, any engagement with us that you would like to pursue, even through R&D, technical services, or technology transfer, of course, it will involve materials development. If in case that you would like to be part of that collaboration, if there are materials that you would like to explore for the prototyping, I think it is the MATDEV who could help you with that. And I believe if in case that we would have a collaboration, para po mas makita natin yung more viability ng project, if in case you would agree with that collaboration, if the product will be acceptable, I think we have the AMCen, tama ba yun, Doc Blessy? The AMCen who would do the manufacturing para po mas makita nyo po yung viability of producing that product. Ganun po siya nagli-link. Ang part po namin ng ITDI is the MATDEV, kaya ini-explain po namin mabuti. It is a very important component of the project. While ang gusto po natin ay makarating siya sa local industry, kaya po naman tayo may AMCen who would do the biggest, the production part para naman po mas makita nyo viable po ba ito in using this local materials in this prototyping using 3D printing technology. So yun po yung collaboration nila. Kaya kompleto po hanggang sa makarating po siya sa industry. So katulad nga sabi ko, we would like to make our stakeholders better understand how the system will work, no? From the MATDEV hanggang po sa AMCen. Para po to mas maging beneficial itong goal natin at ma-achieve po natin together yung goal po ng ating AMCen. While for any inquiries or any letter of request, always please address your request to our director, Dr. Annabel Brones of ITDI. And of course, makakarating po yun sa proper, po kanino man po, mapa sa MSD, to our MSD team or sa TSD team. If in case meron po kaming part doon, makakarating po siya immediately. So yun lang po, to call your attention because we would like to ask for your support. Sabi ko nga po, hindi po itong mangyayari, hindi po natin ma-achieve pare-pareho ang goal. Particularly, malaki rin po ang public funding, no? Ginamit po dito yung public funds. So, kumbaga, explore po natin yung lahat ng possibilities to make use of this platform para po makita natin yung services ng ating MATDEV at the end, yung ating AMCen, yung ating Additive Manufacturing Center. So, I hope I answered your question, sir.
Okay, thank you very much, Ma'am Nelia. And since we are in the topic of collaboration and partnership, Mr. Roger Go of the Philippine Post News Today asked, who are your partners? And are you still open for new partners who wants to join your group? So who are the current partners of the MATDEV laboratory right now? If you could please share. Yes, Engineer Margarito.
So right now, we have collaborations with various institutes. So we have the academe. So we are forming some partnership with the Mariana Marcos State University, Batangas, and we have also from the Philippine Nuclear Research Institute. So we have a memorandum of agreement. And yeah, also with the MIRDC, this is a program being implemented by MIRDC. And we're not limited to that. So we have also partnership with various hospitals. And that we have research on 3D printing, and yeah, we're open naman po yung ating facility for future partnership, so we can do some memorandum of agreement and research to fully gain access to the advantages offered by 3D printing.
Okay, thank you, sir, for your answer. Again, a lot of participants are asking about the contact details. Later on, we will show you who can you reach if you are interested to write a letter to our director, and we also share the brochure or the website of MATDEV so that you can see the rates and the other modes of engagement that we can offer to you. Thank you very much again for your question. Yes,
Can I add something?
Sure, ma'am.
Nakita ko kanina na nag-chat about the costing, no? What we can commit to you is that, of course, we will make all our cooperation or activities cost-effective, di ba? For example, for any R&D activities, we make sure that yung magiging terms and conditions natin will be beneficial for both of us, the DOST as well as our stakeholders. Kasi ang goal po talaga namin dito is magamit yung facility. So we will try to find ways on how we could share our resources to make it more parang dito in terms of value for money para sa ating pong mga cooperators who intends to partner with us. And it's also a one way for us to encourage you to engage in our government facility, government services. Whether it's our R&D, technology transfer, mapapag-usapan po natin yan. And we make sure na yung ating po magiging terms and conditions, whatever contracts na magkakaroon, we will be able to forge, and magiging favorable po for both of us, our stakeholders, and for the DOST. Thank you very much po.
Yes, that's right. As Ms. Nelia mentioned, we do not only offer the facilities and services of materials development laboratory, but also the human aspect. We have here seasoned experts who can give you advice on the proper materials or give you knowledge, added knowledge about the different ventures that you can do with additive manufacturing. So again, thank you very much for that question. And we have another question, this time from the medical field. The concern is from Ms. Josephine Bundok of the Physicians for Peace. A concern is the local sourcing of materials such as filaments for printing. May we be assisted in this aspect? So, Engineer Margarito, do you have any the concern here is about the sourcing of materials. How can you help the medical field in terms of sourcing these materials for their needs?
Yes, that's the initial problem that we have also when we start yung sourcing ng materials, especially those materials that are functional. So we have for the commercially available filaments, we have suppliers here, local suppliers, that provides this filament, but for specific function na materials that we will develop, so we'll have it transferred to a possible cooperator that could manufacture locally the filament. So basically, the aim of MATDEV is to localize the material production if that's possible. So para mag-take off po yung 3D printing technology here in the Philippines, because in other countries they have their supply within their vicinity, so it's much cheaper compared to the materials now that we have here that mostly imported po. While some are recycled, medyo hindi pa siya ganun ka there's a problem in actual printed item or in the printability of this material. So yeah, yun po. So yun po yung aim ng MATDEV, is to make this thing available in the long run, yung filament and other materials that we will be developing.
Okay, thank you so much, sir. Again, just a reminder to our Zoom participants, kindly mute your mics, or if you want to ask a question verbally, you may please raise your hand so that I can ask you and acknowledge you to unmute first. Thank you very much. Okay, so we have another question here from Mr. 𝘿𝙊𝙎𝙏-𝙤𝙏 of 𝘎𝙬𝙀tagalog.net. Could it be possible for us to 3D print an entire car with all its parts and have a working vehicle? Is that possible with the current facilities that MATDEV has? Yes, Sir MM.
Yes, in other countries, no, it's they have tried to 3D print a car, especially those yung electric vehicle kasi yung pinaka-trend ngayon. But some parts may not be 3D printable, like yung engine and or for the motor, because this consists of different materials na hybrid. Another limit ng 3D printer is sometimes you cannot use many materials at the same time. Like for example, in a car engine, so there's a part of ceramic, there's part of metal, and sometimes joining this in 3D printing, it's still limited pa rin. And they have 3D printing a car, they have this optimize the design to yung sa streamline yung to prevent wind resistance, and yung maging lightweight siya but stronger. And you can also design the car just to make yung sa mga impact tests to minimize yung impact or yung damage sa passenger. So it's possible, but not all parts can be 3D printed because of the one limitation 3D printing is yung cannot print. Like yung most car kasi may mga electronics na siya. So like yung mga EFI, so electronic fuel injection. So ang napiprint pa lang for is yung mga circuits or yung pieces, printed circuit board, but the chips, which is in nano size yung mga wires niya. It's not still it's not possible yet for 3D printing, but maybe in the future it's possible to print an entire thing. So there was also a question kung sometimes they use 3D printer to 3D print a part of a 3D printer. So kung for example, if you can have this printer that can use multiple materials, maybe you can have a printer that can 3D print another printer, so para mag-multiply na siya. Kung if we can use this kind of yung multiple materials at the same time, is possible na 3D print a car using 3D printer.
Okay, thank you, sir. Again, it is possible, but not right now. So again, 3D printing, for 3D printing, imagination is your limit. But right now, we still do not have the capacity to print an entire car, but the parts are possible. So thank you for that question. And thank you, Sir MM, again for answering. And we have a question here from Ms. Cindy Dominguez. Are the materials that may be used for 3D printing that are upcycled or recyclable? Are there materials? Yes.
Yes po, no. Based some of our research, so we use nanoprecipitated calcium carbonate. And this calcium carbonate are medyo low yung value niya, but if we convert it to nanomaterial and incorporate in filament making, so we can increase the value of these materials. Same goes with there are projects in some countries to use waste plastics. However, there's a challenge in cleaning these plastics for 3D printing. So if we can segregate this plastic na malinis siya, perhaps we could use this waste na siya into making filaments. And another thing that we also would like to engage in is recycling ng mga used na filaments. So sometimes there are failed prints, and there is this waste plastic like PLA that we can use our facility to recycle this. However, there's kind of a degradation during recycling, and we'll try to do some study or mixing it with the virgin PLA to maintain its performance or the printability. Or maybe we can add more, we can put some additives that will make its performance better or maintain its performance with the virgin resin.
Okay, thank you, sir. We have another question here from Mr. Aris Morataya of DOST-9. Do you have rates for DOST regional offices, perhaps special rates? I believe Sir Carlo can answer this. Since, yes.
Thank you, ma'am. So far, what we have are the usual client rates and the student rates. No? So, well, we can consider this, no, and see if a special rate, no, can be given to our regional offices.
Okay, thank you, sir. Again, the rates for the use of facilities and equipment are posted in our website, so you can visit it for specific, if you are looking or eyeing a specific facility to use, or you are looking for B services, you can visit our website at DOST-ITDI. And okay, we have a question here from one of our partners, Manly Plastics. Does FDM, Ms. Vanessa Ko of Manly Plastics, her question is, does FDM, SLA, and SLS printed products follow conventional material shrinkage? Do you set your STL files with shrinkage compensation? I believe Engineer C could answer this part.
Thank you, po.
Yes, ma'am.
For the question. And yes, we consider po yung shrinkage po ng materials po. And the good thing about yun nga po sa MATDEV is that yung targeted na dimension natin, the actual dimension, can be achieved po, no, through the designing of your file and nung tweaking nung yung STL file. So yun po, possible po siya. Thank you.
Okay, thank you, ma'am.
May I add to that po?
Oh, sure, sir.
Yes, actually yung different materials have different shrinkage methods, and sometimes you need to do trial and error to meet the design tolerance for the item to be printed. And we have parang ginagamit namin is we try to use yung sa simulation, 3D printing simulation. So to adjust for yung compensation for the shrinkage sa design. And sometimes yung hindi lang sa design kasi sometimes yung process will also affect the dimension niya, like yung orientation ng printing. So we'll also look into that para ma-meet natin yung design requirements niya. So we have this software, the assignment pack for additive manufacturing, and it can simulate po yung 3D printing process, and so we can come close to dun sa requirement niya in terms of shrinkage. Sometimes may problem din sa warping, so we could also address it through simulation po ng process.
Thank you very much for your question. Again, aside from the facilities being offered in MATDEV, we also have our experts who knows how to give proper advice so as to the shrinkage of your material and what is the best material perhaps to use, right? So again, thank you for your question. And we have here another question from DOST-9. This one is particularly interesting because we have tackled the field of medicine, automotive, and other sorts of manufacturing. But is there any ongoing R&D 3D printing material in food processing application? Sir MM, yes.
Yeah. So far in our case, MATDEV material science, we're not engaged. Hindi pa kami na-engage for processing ng food, but in other countries they have already done this. Like in Singapore, they have this puree to 3D print foods. Like for example, yung mga chocolate. Imagine a chocolate fountain. So nag-solidify siya. So yung requirement natin is pag nag-lead na siya ng nagiging solid siya. So they use puree for different concoctions of food with sometimes nilalagyan na ng nutrients, so pwede ma-customize din yung nutrients. So ganun. So far they did this for sa mga fruits, sometimes using meat. So they have also conducted this kind of 3D printing. So ang kagandahan nito is they can customize the design para mas appealing siya, and also the the nutrients in color, so mas vivid yung color niya. And perhaps since we can heat the nozzle, you cook the food while you extrude dun sa nozzle niya. So that's so far that's how yung 3D printing for food application.
That's a very interesting question. Thank you, Ma'am Sonora Bunag of DOST-9. So perhaps our food processing division and the MATDEV laboratory could have a collaboration, because this is a very interesting endeavor, because food processing, of course, food is a very integral. And okay, so we have another question. We have a wave of questions here in Zoom, and we have still plenty of time to answer, so keep them coming. Right now, we have another question from Mr. Julius Liano of PTRI. What are the general IT policy for the access of the AMCen facilities for R&D projects? So we now are in the topic of the IT policy. Is there a general IT policy? Yes, sir.
So far, yung mga R&D engagement with MATDEV, we cover it with a memorandum of agreement. So we specify in the MOBA, which is reviewed both by parties and agreed upon, kung ano yung magiging agreement in terms of the IT stuff. So yun po, ganun po yung magiging engagement niya, together also with the AMCen.
Okay, sir, thank you. Okay, another interesting question here from Michael Lance of PhilIT.org. How can tech startups gain access to these services from MATDEV? Sir Carlo perhaps can answer this one. Services. How do you engage with tech startups?
Okay. So again, so this is a great opportunity for us to invite different stakeholders, especially our startups. So you can always address your inquiry to our director of DOST-ITDI, and then from there we can set up probably a meeting, and then we can see how we can work together, how the startup company and MATDEV can work together to achieve your ideas or your projects. So it can be from design up to the final product, or maybe what you just want is the use of a specific equipment. So we can set up that we can have that kind of setup. So just contact. So again, so just contact our director of DOST-ITDI. So I think the contact details are also presented here. So you can contact us through email, basically through email. So because of the new normal.
Thank you very much, Sir Carlo. Again, for questions about collaboration or how you can gain access to different services and facilities, what you need to do is to write a letter of intent to our director, Dr. Annabel V. Briones, and later on we will give you the contact details and the email addresses where you can send in those requests. So, okay. Now we have another question here from Facebook. From Dana Abad. In the near future, will the technology of 3D printing replace the modern? In the near future, will the technology of 3D printing replace the technology of injection molding? So we're back in the field of medicine. So do you have technologies on injection molding as of the moment? Yes, Ma'am Joanne.
Yeah. So the question is if in the future, 3D printing will be replacing injection molding. Well, in my opinion, 3D printing is here to complement whatever conventional process that we have. In the first place, injection molding is intended for mass production. And in that sense, it is still cheaper to mass produce items using injection molding. But yung cost efficiency, papasok lang po yon in the prototyping stage kasi mas mahal kapag yung magpo-prototype ka using the conventional way, but let's say you just want to test yung effectivity nung gagawin mong new product o new developed product. So maganda, doon papasok yung advantage ng 3D printing kasi mas mura kapag sa prototyping pa lang. But then, siguro malabo pa na i-replace niya yung injection molding. That would be, thank you.
Okay, thank you.
May I add po?
Sure, sir. Go ahead po.
May I add? There's a break-even point. No? Yung ilan yung po-produce mo, that is parang advantageous yung, yung injection molding. But in some applications, they have tried to yung 3D print yung mold mismo. So ito kasi yung mahal na component for injection molding. So if this is more viable, kasi ang advantage ng injection molding is for mass production, as mentioned by Joanne. But for 3D printing, the advantage is mass customization. So i-customize mo na design. So kung gusto mo iba-ibang design, you can use 3D printing po. So, ganun po yung parang magiging feature nung or advantage, magiging scenario for compared ng injection molding with 3D printing. But it's more compared to mass production, mas less po yung cost ng injection molding.
Okay, thank you very much for your answers. And we have another question here from PTRI, from Dave Brian Nakabansad. Can I ask po if concrete mortar is supposed po for 3D printer or cement mortar with additives? Concrete mortar for 3D printer or cement mortar with additives.
Yes po, no? So may mga application na for 3D printing ng mga structure. So yung the record is parang FDM din siya, but instead of filament na melted, you have the concrete mix. And yung one requirement for that is pass setting dapat yung ating concrete mix, and perhaps they put some additive para mag-set siya faster than the usual concrete mix. And in some applications, like for example, yung sa NASA, they looking at 3D printing to just in case na matuloy yung kanilang plan to parang sa Mars, they want to use 3D printing to build the structure sa Mars using yung mga raw materials that is present there. So yun po yung in terms of sa structures, it's possible na po to 3D print structure using some fast setting na concrete mix.
Okay, thank you, Sir MM. We are again receiving questions here about collaboration. So again, we will show the contact details where you can send in your letters of intent for any possible collaboration or the use of services. So thank you for your questions. We have here a question from A. De Leon of Bid and Bytes. Is the cost of production part of the disadvantage, for example, on face shields? So is 3D printing costly? Anyone can answer?
Yes, but it will depend on the application. For the face shield, mas advantageous po yung injection molding because it's a mass production. You can print maybe 1 piece per minute compared to 30 minutes or 1 hour face yung frame for a 3D printer. So yun po yung But if you for specific application like for sabihin natin sa dentures or sa dental applications, advantageous yung 3D printing compared to conventional since mas less cost siya and mas faster po yung yung product production ng product compared to 3D printing kasi customized siya. So yun po yung just weigh in po yung it will depend on the application. If it's highly customized, you can have 3D printed po. If it's kung same design, then you can have a conventional production systems po that is less cost compared to 3D printing. So just like John said, both technologies yung would compensate each other.
Okay, thank you, sir. So it again depends on the situation whether we'll not 3D printing will be more expensive. So again, we have a wide array of different materials that we can use. And again, thank you very much for that question. So we are now down to our last few questions, and I will just choose some of the questions here that have not yet been asked. And we have here one from Jackie John Felix of Filmec. So we are in the field of agriculture naman po, ano? So part of our innovation for precision agriculture is to optimize component of machine, which will result to complex shape of the subject component. But the problem is we do not have a 3D printer component which requires metal materials. Do you have a 3D printer capable for 3D printing metal parts? So does our MATDEV team have facilities that can enable printing of metal right now? Is it possible? Yes, Engineer C.
So MATDEV at the moment does not have the metal 3D printer, but the facility that MIRDC have, AMCen, being managed by MIRDC, they have the printers for the metal parts. Thank you.
Okay. I hope that answers your question. We have here an interesting question about policy and regulation. So we have a question here from DOST-PTRI. What are policies or regulations does the country or AMCen have with regards to 3D printing? For example, printing of firearms or harmful objects must be regulated. Hoping you could share some legal restrictions or limitations of 3D printing for everyone's information. Yes, Dr. Please unmute, ma'am.
Yeah, sorry for that. Actually, that was currently, we don't have the 3D printing laws as mentioned. That is the reason why we are establishing the Technical Committee 88 to be able to address issues with regards to 3D printing, especially in the area of firearms. So we have inline different standards which will be reviewed by the Technical Committee, and this will include that area. So we are in the works on establishing our standards, but I would like to emphasize that these standards are not compulsory. No, these Philippine national standards are voluntary. You could use it as a reference, but it is not a compulsory standard unless we have a body, a regulatory body that would require for us to use the standard that has been established by TC-ATA. Okay, so that's it. Thank you.
Okay, thank you very much, Dr. Les. Again, just like new innovations, of course, there is also a need for regulation so that other people will not take advantage of these technologies. Of course, we aim that 3D printing will be the use for the use of the common good. So thank you very much for that very good question. And finally, as much as we would like to answer all your questions here, we are down to our last one, but you could still email us your questions. Later on, we will flash the contact details of the MATDEV team so that you can address your questions to them. So we have one final question. This is particularly interesting. It's from our partners from Erie, Mr. 𝘿𝙊𝙎𝙏-𝙁. How can we maximize the use of the technology on 3D printing or the facility itself to bring benefits to the agriculture industry, especially to the farmers in the countryside? What kind of business model is viable or suitable to realize this? Does the MATDEV team have any initiatives for the agriculture sector, perhaps?
I'll answer for you. So for one of the I think the industry that could take advantage of 3D printing is the agriculture sector. So if you watch Facebook, so maraming innovations, no? Like in India, they have innovation in planting or harvesting. But yun nga po, with 3D printing, they can do some tweaks, modifications in the designs to maximize po yung ano. So we at AMCen, so tomorrow we'll have another stakeholders forum, you know. So they have identified specific industries that are priority for AMCen, or para yun yung ano, one of them I think is agriculture, kasi there most of the parts needed for agriculture are metal parts. So that will be the service of the AMCen or the Rapid ADMATEV for the prototyping. We can also assist dun sa development of the materials that are requirement through our aming spherizer. So we could work hand in hand to address the needs of the agricultures, kasi maraming requirement. I think they can benefit dun sa with the 3D printing. So given yung I was browsing through the questions also na I have not mentioned. So maraming application din sa agriculture yung 3D printing, and in fact a lot of research also, or more on prototyping talaga siya. And that would be the area of Rapid ADMATEV. So if you have designs for you want to 3D print, we can avail of the services of Rapid ADMATEV for prototyping, particularly dun sa agricultural applications.
Okay, thank you, sir. Yes, Ma'am Nelia, please.
Can I say a few words before we end our Q&A? Kasi as part of the organizing team and as a follow-up dun sa questions about the objectives and rationale of this stakeholders forum, I would like to inform everyone that I think we met our goal, no? Yung aming objective for organizing this event, because we have seen that we have aroused the interest of everyone. Napakadami pong questions, no? Well, in fact, ang mapapromise po namin sa iyo, doon sa mga hindi pa po nasagot, we will try to consolidate. Our team will try to consolidate all these questions and work closely with our MSD para po ma-provide po namin at masagutan lahat ng mga clarifications nyo, no? And also, ang isa pang na-achieve namin is we were able to get pertinent feedback from you, which we think will serve as our basis, of course, the MATDEV group, to pursue yung mga future plans nila on how to make their service offerings more relevant to our stakeholders. Maganda po yung lahat ng mga feedback nyo, kaya medyo natuwa po ako at na-overwhelmed, no, with all these questions and the reactions you gave us. We are really very, very happy. Ang isa na lang pong inaantay ko is your commitment, no? So, kasi po, yun din yung isang goal namin, is for you to partner with us. So, syempre, we will get there. I know, makakarating din po tayo doon. But it won't stop us from kayo po, yung aming mga stakeholders, to keep on making some increase, clarification. Sabi ko nga, any request addressed to our director, Dr. Annabel Briones, who is also with us here. So, thank you. Natutuwa lang po ako as part of the organizing team, no? We make sure na kung ano man po yung mga pwede pa namin ibigay, we will get back to you sa mga questions na hindi po natin meron pa ba tayong maraming questions na hindi pa na-address? We will respond to you. TSD team, please take note of that. Thank you very much. And ang media friends pala natin, please help us spread the good news about MATDEV. Kayo po ang kailangan namin. And of course, yung mga industry na nandito. Thank you po.
Okay, thank you, ma'am. Yes, Dr. Annabel. Yes.
I also say some few words, no? This is a very successful event because we were able to promote the MATDEV laboratory of ITDI as one of the projects of the AMCen. No? So this coming April, the Additive Manufacturing Center will also be inaugurated. No? So in April. So this is already a good opportunity to invite all of you here to attend the inauguration that will be spearheaded by Engineer zone of the MIRDC. And we are also hoping that President Duterte would be there to attend the event in April. We are hoping for that. And actually last Saturday, I think, I was promoting this event sa Global Pinas TV radio of this forum. Si Ms. Nes Aguilar was the one who was anchoring the interview. And in fact, I also would want to show sana last Sunday yung video, but hindi na kinaya kasi it was late in sending it to them. So thank you for that opportunity that this activity was promoted, ahead of time. And yes, the MATDEV laboratory is open to all. So we are ready for collaborations, partnerships, and especially for research and development. Kasi itong MATDEV Lab is for R&D. So ang dami yung mga ideas, mga tanong, please do come and visit one of these days the MATDEV Lab. Just inform us ahead of your visit, or you may email directly to the MATDEV team. I think we have a website for the AMCen, Doc Blessy, and so they can also browse the website for the AMCen. So nandun ang mga services, not only ITDI but also the services of MIRDC. Kasi sila yung advanced what we call this prototyping in a bigger scale. And then for us, ITDI, we are more on the multiple materials development. So please come, feel free to collaborate with us, especially the academe, the Fab Lab, and also the hospitals, the medical sector, who are really needing this kind of technology and services. So we DOST, through the leadership of Secretary Fortunato de la Peña and our Undersecretary Cristina Guevara for R&D, really supported this project because we need this, and advanced manufacturing or additive manufacturing will stay and we need this to advance us, especially on the manufacturing side. So thank you very much. We have a very good participation, and this is not the last engagement that we will be having. We will be doing a series of webinars. We will be also offering some trainings on the 3D modeling, etc. So abangan nyo yan. This is just the beginning of our MATDEV engagement to the public. So thank you.
Thank you very much, Dr. 𝘿𝙭𝙎. So since we are having a surge of questions here, especially from the media, we are very much thankful for your attention and your participation. We will address all the questions of the media after having our closing remarks. So we will first have our closing remarks, and then those who still have questions can stay with us. We will not end this Zoom room yet. So you still have the chance to ask your questions to all our experts and speakers. So let us just first proceed with the concluding remarks to be given by the OIC Deputy Director for R&D and the Chief of the Packaging Technology Division, Ms. Stacy E. Tanya Franca. Good morning, Ma'am Daisy.
Good morning, everyone. A blessed and safe morning, everyone. I guess I have nothing more to say because Doc Annabelle and Ms. Nelia have already made the commitment of ITDI. But first, let us congratulate MSD and PSD for a successful stakeholders forum on MATDEV. So, palakpakan po natin sila. And then second, we would like to thank the DOST officials led by Secretary 𝘿𝙊𝙎𝙏 and Usec Gev. Hindi lamang po sa pagdalo today, but also for always supporting ITDI in many projects, which include MATDEV. Third, we would like also to thank the participants from the industry, from the academic institutions, and also from the media. All technologies that we develop, innovations, research activities that we do here at DOST are for the industry and for our country. Ang tagline nga po ng DOST, Science for the People, para kay Juan at Juana. So our speakers have given all of us the information about MATDEV. Ang dami ng questions, ang dami ng exchange of information, and future collaboration. So maraming salamat po. By the way, kami pala sa Packaging Technology Division is also using 3D printing technology for the development of packaging design. So unlike MATDEV, they cover a range of products. In our case, we're very specific with packaging design. So yun po ang gamit ng 3D printing technology on our division. So aside from this forum, there are a lot more upcoming events. So please always check the website of ITDI and DOST. So para malaman niyo po kung ano pa yung mga upcoming events. I will no longer keep everyone hungry kasi it's almost lunchtime. So on behalf of our director, Dr. Annabelle Briones and Material Science Division and PSD, maraming pong salamat for attending this forum. So God bless everyone, and thank you, Lord, for the opportunity to share our technology and knowledge in this forum. So marami pong salamat.
Miss Meg?
Yes, po. Yes, Annabelle.
We would like to acknowledge the presence of our Assistant Secretary, Dr. Diane Ignacio. She's here.
Yeah, pasensya na. Oo, congratulations, MATDEV. Congratulations, ITDI. Yeah, medyo I was in 3 other activities, so at least narinig ko naman yung iba, and really very, very impressive MATDEV we have at ITDI. So I hope na we will be able to utilize all of them, and our customers and stakeholders can avail of what we have at ITDI. So maraming salamat and congratulations.
Thank you, Asik Dayan.
Thank you very much, Asik Dayan, for gracing this event. Thank you very much again to the other members of the DOST EXICOM and MANCOM for participating as well, and to the different R&D institutions who are also with us. So again, just a reminder to those who still have questions, most especially to our media friends, again, very thank you. Thank you very much for your active presentation. We are staying behind. We are still not ending the Zoom session so that you can give more questions to our moderators. So please do not leave just yet. And for those who have other engagements, you can see that our contact details are flashed in the screen. So if you are interested for any collaborations, just send in your letters to our director of ITDI, Dr. Annabelle V. Briones, and flash in the screen are the contact details of the different divisions of ITDI. So again, thank you very much for your attention. To our media friends, please stay with us still. We still have time to answer your questions. And of course, for the webinar evaluation, to secure your certificate of participation, kindly accomplish the evaluation form at bit.ly/MATDEV Forum Evaluation, or you can scan the QR code shown below. This will be available until 3 p.m. today, so kindly accomplish this form so that you will have your certificates. Again, thank you very much for your attention and have a wonderful day. Thank you for participating to the AMCen-MATDEV Stakeholders Forum. Again, to our media friends, kindly stay behind so that we could address all your questions.